Imagine staring at a wall of dense, abstract cryptographic equations. Compare that to the frictionless experience of swiping open a dating app on your phone. The bridge between these two extremes is a concept called a zero-knowledge proof, or ZK. In short, ZK allows you to mathematically prove a statement is true, like proving you have enough money in your bank account, without ever revealing the raw data itself. For years, this was locked away in academia. Generating these proofs required massive computational power, making them a slow, theoretical tool used almost exclusively by a small group of niche cryptocurrency privacy advocates. Recently, the math caught up with reality. This obscure cryptographic concept has broken out of its niche to become the hidden engine powering both radical crypto privacy and everyday consumer tech. This chart tracks the market capitalization of the zero-knowledge cryptocurrency sector. It shows a rapid surge, hitting a $9.01 billion valuation, driven largely by huge trading volumes in top coins like Zcash, POL, and ZK-Sync. It's worth asking why a highly complex, historically sluggish sector suddenly exploded in value and trading volume right at this moment. The answer lies in three converging breakthroughs happening simultaneously: a massive leap in hardware acceleration, new cross-chain unification protocols, and sudden adoption by major tech. Generating a zero-knowledge proof requires proving every single step of a computation. Historically, doing this took a brutal, time-consuming amount of processing power. This conceptual diagram shows a processing pipeline getting choked by two specific mathematical operations: multiscalar multiplications, or MSMs, and number-theoretic transforms, or NTTs. MSMs combine many points on an elliptic curve into one, while NTTs speed up the multiplication of large polynomials. To clear that bottleneck, developers created software solutions like ZK-Sync's Airbender, optimized to run these calculations in parallel. This means proofs can now be generated quickly on standard consumer graphics processing units, or GPUs, instead of relying on massive, expensive data centers. Standard GPUs are only the beginning. The industry is currently escalating to FPGAs, field programmable gate arrays. These are specialized hardware chips that can be physically reprogrammed on the fly to process zero-knowledge math faster than a general-purpose graphics card. The ultimate hardware endgame is the ASIC, or Application-Specific Integrated Circuit. Designing an ASIC requires multi-million-dollar investments and years of lead time, but because the chip is hardwired to do exactly one specific mathematical task, it will process ZK proofs orders of magnitude faster than anything else on the market. Conquering this hardware and software computation bottleneck is the prerequisite step. By making proof generation fast and cheap, the entire sector gains the ability to scale up to millions of users. This network map illustrates the unintended consequence of all that rapid scaling: massive network fragmentation. You see isolated, disconnected clusters of glowing nodes representing different rollups, secondary networks built on Ethereum to process transactions faster. Because they are isolated, they can't easily share users or resources. To fix this, developers are building new protocols like T1 that connect the ecosystem using Trusted Execution Environments, or TEEs. A TEE is a secure, isolated area inside a computer's main processor that guarantees code is executed exactly as intended without being tampered with. By utilizing these secure environments, T1 provides real-time proving. It acts as a universal translator, instantly verifying execution between different, isolated Ethereum rollups. This allows developers to build cross-chain applications that draw from a single, unified pool of funds. The messy, fragmented infrastructure is completely hidden away from the end user. While hardware and cross-chain solutions refined the back-end infrastructure, a separate wave of validation emerged from outside the crypto industry entirely. Google recently integrated zero-knowledge proof technology directly into Google Wallet to handle consumer age verification. This means a user can prove to a third-party app, like Bumble, that they are over 18 years old. The app gets cryptographic certainty that the user is an adult, but the user never hands over their actual birth date, their physical ID card, or any other personal data. This integration moves ZK math out of the theoretical lab and into a production environment used by millions of smartphone users, setting a new benchmark for digital privacy on the mainstream internet. Over the last few years, zero-knowledge technology matured from a tool for hiding financial transactions into the definitive infrastructure for scaling decentralized networks and protecting personal identity online. As custom-designed ASIC chips hit the market over the next 12 to 18 months, proof generation time will plummet to near zero. And as cross-chain protocols like T1 unify fragmented liquidity pools, the clunky technical friction of navigating cryptocurrency networks will simply disappear. That $9 billion market cap represents the cost of a massive internet upgrade. Very soon, zero-knowledge proofs will function as the invisible, ubiquitous engine keeping our digital lives fast, connected, and entirely private.